Welcome to Operations Research Sensitivity Analysis Lecture Series by Professor Joyjeet Ghose. This is the third lecture of a 4-series lectures. This lecture will be on sensitivity analysis. He will also be discussing the sensitivity analysis of change in the objective coefficient of a basic variable by conventional simplex method. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture 3 in the 4 lecture series. In this lecture, we'll be discussing the change in objective coefficient of a basic variable in sensitivity analysis, or rather how to do sensitivity analysis for a change in the objective coefficient of a basic variables. And to understand that, we have taken this problem. This problem I have discussed in the first 2 lectures also. So if you have seen the previous 2 lectures, you might have already solved this problem either by conventional simplex method or by revised simplex method. So first thing that we have to do to understand this lecture is that we have to solve this problem. So if you have not solved this problem, please pause the video at this point of time and solve this problem, and then you can check your solution with mine, and we will be following a conventional simplex method in this particular lecture. In the next lecture, we will be using the revised simplex method. So here, first solve it by conventional simplex method. So if you have solved it by conventional simplex method, your result should match with that of the mine. So the solution here is that x3 is this one, that is 6 by 5, and x1 is 27 by 5, and z is this. So now the question is, if the coefficient of the objective coefficient of a basic variable x1 and x3 are basic variables, so if this change or this change, how does it affect my result? How does it affect my solution? Will it affect my solution? So let's say this changes to c1, and we will be concerned with this table only. Other iterations, this iteration and this iteration is not our concern. Our concern is only this iterative table. And we'll check whether the solution will remain optimal, and if it remains optimal, up to what value of c1 that it will remain optimal. So this is the sensitivity analysis we'll be carrying out in this particular solution. So you might have solved it by conventional method, so we'll be discussing this by conventional method only. Okay, so here, now once this changes, if this is changed to c1, now how or what is affected? Is this affected? No, these are not affected. These are not affected. These are not affected. What is affected? What are the values that are affected? All these values will be affected. These 3 equations will change. That means this also is affected. So 4, in place of 4 we have to write c1. So this is also affected here. So this I'll cut and I'll put c1. So this into this plus c1 into this. So 5 into 1 by 5. So 5 by 5 into plus here, this will be c1 into 7 by 5. Okay, so 3 minus this thing should be less than equal to 0. So if you solve this like this, there will be 3 equations here, this equation and this equation, again 10 by 5, sorry, here 0 minus 10 by 5 minus C1 by 5 should be less than 0, and the third equation will be this into this is minus 0 minus 5 by 5 into C1 into 3 by 5, again this less than 0. So we'll solve these three equations. So solving these three equations will give us this and this. So from these three, this all should be less than equal to 0, less than equal to 0, less than equal to 0. So then only it will remain optimal. So it comes out that C1 should be greater than 10 by 7, C1 should be less than 10, and C1 should be greater than 5 by 3. So the range comes is that 5 by 3 less than C1 less than 10. As long as C1 is within this range, the solution will be optimal. So if it becomes out of range, then it will be not optimal. So if C1 is equal to 9, the solution will remain optimal. If C1 becomes equal to 12, the solution will be not optimal. So therefore, let's say if I change C1 to 12, then how we'll find the optimal solution? Finding out the optimal solution, if C1 becomes equal to 12, then we'll check. So C1 I have changed to 12 here, so this comes out to be positive. So therefore this is the entering variable, x4 is the entering variable, and x2 is the leaving variable. X4 is the entering variable, and then we'll solve it and we find out that this is the solution. X4 is and x1. So solution is basically x1 is equal to 6 and z becomes equal to 72. So this is how you solve the sensitivity analysis for change in the objective coefficient of basic variables by conventional simplex method. I hope this is clear to you. If you have any doubt, please feel free to ask me and I will try to clear the doubt. Thank you very much for watching this video.